Yeah, well, thank you very much for this opportunity. My name is Heiner Lehr, and I'm going to talk about robotics and AI in chicken production. I come from a company that is called Faromatics, was founded almost 4 years ago by this group of experienced gentlemen, and we've now grown to 17 staff. And what we're doing, or we're trying to do, is to make livestock farming more acceptable and more practical through the use of precision methods. So we come out of the precision livestock farming movement, if you wish, that I personally have been involved in for more than a decade in Europe. We're focusing right now on poultry, but with the idea of going, of course, to other species. And the reason why we're focusing on poultry, and particularly on broilers, is because there is, quite a lot of them. So we are raising about 60 billion of them every year, 3 billion of which never make it through the process because they fall ill and die. They eat 250 million tons of feed every year, 3 million of which we could easily save if we had better digestion management. And some of them, they suffer bruises and scratches, and they are not allowed into the human food chain. And we could save at least 300 million birds from going to waste, so to say, if we had better stress management on farm. That's what we're trying to do with this robot. We call it the chicken boy. And here you should be seeing a video of how the chicken boy moves around in the house. As you can see, one distinctive thing is that it moves on rails. So we have hung it under the ceiling of the farm. The main reason for this is that we have access to the flock from the first to the very last day. Those robots that do also exist, that go on the ground, we call them rovers, they cannot get through these densely packed chicken houses after day 30. So that's how we are trying to solve the problem. As you have seen, others like iOS 2020 are trying to solve the same with sensor networks. But this is for us, with all the sensor technology that we're packing into the robot, is a bit difficult from the cost perspective. So the robot is completely autonomous. So the farmer hangs the robot into the house and then forgets about it until he has to take it out again when the production cycle is finished. We monitor 3 different areas: ambient conditions, health and welfare, and equipment failures. And we do so, of course, with the input of a lot of sensors, but mainly through machine learning, so artificial intelligence. So in more detail, what we're doing is we look at the excrement of the chickens. So we find fresh excrements and we classify them. Relatively simple at this stage, so it's good or bad, really. So, and with this, we find early onset of intestinal diseases. We can find them 24 to 48 hours before the farmers, not because we are so much more clever than the farmers, but because we're doing it constantly, 18 hours a day. And we write down the results. So we know exactly how many we found an hour ago, 3 hours ago, 5 hours ago. And that gives us this power to find that onset early enough. Finding early onset of the intestinal diseases means very often the difference between antibiotics and no antibiotics. So this is a win-win-win. The chickens get less ill and die less. The farmers have less money to spend on medicine, but also on mortality. And the consumers get less antibiotics in the supply chain. We also do other recognition tasks. So we find defective drinkers, like in the video here, and you will see that from time to time this is still work in progress. So we also detect, from time to time little chicks. Now there's one. We find mortality, and we find wet spots in the litter. All 3 of them are important for both welfare and productivity of the animals. So we help farmers keep the farm cleaner, so less infectious disease sources. We help them manage polydermatitis better, and we help them guarantee that the animals actually have access to water sufficiently. We also do maps of thermal comfort, so that will be temperature, relative humidity, airspeed. So something like, how are the animals actually experiencing their environment, air quality, that is carbon dioxide and ammonia, and light and sound. So we can study, for example, here's a graph. It's a bit difficult to understand. Don't worry too much about the details, but basically we're looking on top, like if it were a bird, we're looking on top of a farm, and we are looking at the differences in both in air quality, basically, so both ammonia and CO2 in that farm over a whole round. So we're seeing that the farm building is clearly non-uniform. The air is distinctly worse in the front part of the building than it is in the back part of the building. And it's that kind of optimization potential that we have here that will allow farmers to gain these percentages in productivity that we want them to gain. Of course, remote monitoring, so we can stream, we can take photographs, and we have alerts, about 15 of them, that alert farmers of any kind of situation that they need to be alerted about. And the technology is, very cool. We're working on new features all the time. But the really cool thing is that we can demonstrate that this makes extra money. So in the line of what was said before by IOF 2020, by Technica, is, we are finding where we can document now that welfare, investing in animal welfare actually makes more money for the farmers. So our robot pays back in under 2 years, and it creates 60,000 euros extra profit over 5 years for 40,000 chicken farms. Our main clients, however, are large integrators. So these integrators know that they need to produce better, so more with the same capacity, because it's very difficult to get new licenses, and therefore, it's the growth which really comes from reducing things like mortality or improving feed conversion. There's a lot of money in that, so a percentage point improvement in mortality generates 1.2 billion euros extra profit to the industry. So it's an enormous amount of money that is linked to these key performance indicators that, of course, also impact very much the welfare of the chickens. So what we help them with here is more insight, better control, and increased transparency for their operations, and that's why these integrators are quite interesting. We are currently in 5 countries. We would be in 6 operational if it weren't for COVID, but we're hoping to be able to get that up soon. The technology that we're using is applicable to 1.3 million animal houses worldwide, nicely growing, 1.6% predicted by FAO. This creates a 9 billion euro market. Our market share our share of that, the serviceable addressable market, is tiny right now because there is so little penetration of robotic products in livestock farms, but it will break through the billion euro barrier over the next 2 to 3 years. And in order to make that growth happen, we partner with Big Dutchman, the largest provider of agricultural machinery and technology for pig and poultry farms. A German company, a billion-dollar company of its own right. And for this effort, we have received a number of rewards already. There is a new one that I haven't put up yet. And I think this is probably a short run through what Faromatics is doing. So thank you very much for your attention, and I look forward to your questions.